Hello, everybody? Hello? Thank you. Really pleased to have the opportunity tonight to have J.B. Straubel join us. He's the Chief Technology Officer of Tesla, co-founder of Tesla. He's been there from the very beginning, that's right, from the very beginning. And he oversees all the technical directions of Tesla. He's also central to Tesla Energy and what they're doing with their Gigafactory. He's been named Innovator of the Year, Engineer of the Year, and I think we all know that it's been an extraordinary achievement to create the first new automobile company in the United States since Chrysler was launched in 1925. And tonight, we'll have the opportunity that whatever gave that crazy idea that this was possible. So I might just start, JB, by just asking a little bit about you. When did you just become an engineer? When you were 11, 12? I mean,
Well, I've always loved technology, and I actually thought I was going to be a scientist, more than an engineer. I was always conflicted back and forth between science and more applied science or engineering, and it wasn't until almost 2/3 of the way through college that I even really finally buckled down and declared a major and moved toward engineering. But I actually defined my own major and ended up defining a major called Energy Systems Engineering.
So that did you just go to some professor and say, that's what I want to do?
Well, it was close to that. It was lucky to have a very flexible institution that really
Stanford.
let students follow their passion, and I loved.
So what was the name of the major?
Energy Systems Engineering.
Are you the only person in the history of the world who's done it?
Well, I think at this point, they actually have a whole track, focused on energy. I'm pretty jealous.
Yeah.
When I was there wasn't too much to do.
All right. So, but as I understand, you actually built your first electric car when you were 12 or 13.
Yeah, before I had a driver's license. It was kind of a souped-up electric golf cart that was a whole lot of fun.
Did it work?
Oh, it worked. It worked well. It was maybe a little too dangerous, but.
Right. So, did you come from a family of engineers? I mean, when did you realize that this is what you like to do?
No, my immediate family are more entrepreneurs, actually. My dad was a kind of classic entrepreneur and started a few businesses, not engineering related, but far back in my family there was more engineering and kind of inventor history, so it's kind of fun to read about that.
So, if you go back to, so you went to Stanford, and then what did you do after Stanford?
Well, I'm an entrepreneur at heart, and I never really settled into kind of a normal or regular job. I kind of struggled to.
You didn't have a 9-to-5 job?
I never had a 9-to-5 job. I kind of fell in love with solar car racing, actually, when I was at Stanford, this crazy sport of building these kind of spaceship-like cars that run on, about the power of a hairdryer and try and drive across Australia or the U.S. So, I stayed involved in that for even a whole year after I graduated, to the chagrin of my parents.
Right. I mean, if you think back to when you became involved with this idea, I mean, so when do you think you really became interested in the idea that there was a need and a reason for an electric car? Can you remember back?
Well, I think, even in the very, early days when I was just starting college, that was when I really sort of, I think, fell in love with the idea of, coupling sustainable energy to sustainable transportation. And, the best way that I could see to do that was through electrification. And, to me, the technology is just fascinating. I love batteries. I love power electronics and motors, and, coupling that with solar and wind. It's just fun. I can't imagine working on something more fun.
Right. Could you? I mean, but you never imagined when you started where you'd be today, or did you imagine?
No, definitely. I never imagined, that things, would scale and grow as quickly as they have. I think, we had a vision for a future, that involved almost everything being electric, which is still the same, vision that we're chasing and working to achieve today.
So, you graduate from Stanford, you don't really quite have a job. Your parents kind of a little concerned, you have these degrees, no job. So how did you fall into sort of working on electric cars?
Well, it was a strange story, but I was trying to build an electric race car, actually, that was trying to set a world record for range. How far could we go on a single charge? And we had this crazy idea of stringing together about 10,000 laptop battery cells and jamming them into a car and seeing if we could drive this car.
So you already saw the possibility of taking laptop batteries and...
Yeah, well, it was I've known of possibility. It was kind of a crazy idea at the time, and frankly, I wasn't really chasing after imminent commercial goals for this thing. It was more just can we do it? Let's set a world record. This is going to be great. Show the world that electric cars can be cool.
What are you living on at the time?
Well, I was doing engineering consulting work at night, so that kind of paid the bills.
I say this as a parent, so.
But it was such a fun project. I just loved this thing, and I recruited all my friends. I got the Stanford solar car team to kind of, in between races, to give up their solar car thing and come and work on this crazy electric car. And I went off shamelessly looking for anybody that would back and support this thing. And that was ultimately what led me, to run into Elon Musk.
So there is this story about this famous lunch at a fish restaurant, which didn't start off to be about electric cars, it was about something else.
Well, that was another thing. This is always a crazy story. Another thing I was trying to do was build an electric airplane company, which was a little bit ill-fated.
Also ambitious, yes.
There were a few different things in parallel. And this lunch with Elon was initially about him being involved or trying to help support an electric airplane company that I was working on, and another famous engineer in Los Angeles named Harold Rosen was working on.
And then tell us about the lunch.
Well, it was interesting. Elon was kind of and at the time, he was a famous guy, nowhere near as famous as he is today, but still intimidating. And we were passionately making this pitch for this long-range airplane, long-endurance, unmanned airplane. And
with lithium-ion batteries?
It had hydrogen and lithium-ion batteries. Right. It was pretty complicated. And we got halfway through the lunch, and he just said, that's not going to work. I have zero interest in that. So, it was kind of a reboot on the lunch halfway through. And, we just sort of started enjoying the food. But, we did, I thought, what the heck? I might as well start telling this guy about some of my other hobbies. So, we started, talking about, there's also this electric car project that we're trying to do, and, it's amazing how the lithium batteries have really advanced what electric cars can achieve. And, he immediately got excited about that, more than anyone else I had talked to, and he immediately got it. He could see the potential and sort of understood what the impacts were of what we were talking about. So, that was pretty exciting, and, it was really the sort of turning point when we connected, and he sort of brought in this very, very much more aggressive business picture into the whole thing, thinking this isn't a world record race car, this is a new business.
So he got it right. So he not only picked up the check, but he wrote a check.
It wasn't immediately at that dinner or at that lunch, but in the few weeks following, we followed up several times, and it led to him basically launching Tesla.
So how did you go about organizing it at the beginning?
Well, there were 5 of us in the beginning that all came together, kind of with different skill sets. And my background was on all the energy storage, conversion, kind of the whole propulsion and technology piece of it. We had a founding CEO, we had a founding CFO, Elon was founding chairman, and another founding kind of engineering leader. And it was a kind of motley group, but that group got together to try and build or start to conceive of what became the Roadster.
So what was the first big thing that you had to think about?
Well, there were a whole bunch of complicated problems. One was how the heck were we going to actually build a car? We had no shop, we had no factory, so we had to think about who could we partner with, and how could we convince some car maker that would be crazy enough to cooperate with us and build an electric car. We also had to make it work. We had this harebrained idea that we could use what were then basically only laptop cells and power a car. Today lithium ion is everyone in the automotive industry thinks about lithium-ion, but then it was innovative, borderline insane.
Right.
So that was a pretty tough thing to both make safe, make reliable, and design systems around.
Right. Of course, one of the other ideas or concepts you had is, GM's effort at an electric car had been described as an egg on wheels. And I think you decided going for a roadster is a little different.
Well, I think we had seen, a whole landscape of wrecked and failed EV startup companies. There were dozens when we were starting it. I mean, this was also part of what made it insane, is you could just point to the failure, failure, failure. And most of those companies were focused on, ultra efficient, very, odd-looking, kind of, vehicles that we sometimes called punishment cars.
Right.
It wasn't something that was for driving, aficionados that loved cars and loved driving, but it was for people that kind of, almost didn't want to drive. And, that. So we felt there's no way that we're going to get adoption and really change people's mindsets, make the technology cool, build a cool brand if we were starting at that end of the spectrum. So we went all the way to the other end, looked at where the technology was best, and realized that high performance, acceleration, torque, and even range, with lithium batteries were things we could do very well.
All right. So what was the basis for the Roadster as a sports car? I mean,
well, it was closely built off of the Lotus Elise.
right.
So Lotus was the company that we ended up finding that would work with us and would help us build that car. And in the beginning, we had this concept.
Did they think you were crazy too? Or?
Well, they definitely kept an arm's length.
Right.
It was every single thing we did was really hard in the beginning because they were convinced we would fail imminently. So everything had to be carefully guarded.
Right. Do you think so? Was the aha moment for you? I mean, there are probably many of them, but was it this thought to harness the lithium-ion batteries rather than some other way of approaching it?
Well, I mean, it seems very simple today, but I think the biggest aha was realizing the sort of positive feedback as you can have more energy in an electric car. Suddenly you get fewer cycles on the battery. You naturally get more power capability. You get better handling and better acceleration because the battery is getting more compact as the energy density goes up. And when we first kind of did the numbers and just had a really simple Excel model of this car, it was very unintuitive what it could do, the Roadster. And even as we were pitching this idea, many people just thought we were lying. They said, well, there's no way you can build an EV that has 200 miles. It's just, you're lying. And I think it.
What do you say to people when they tell you you're lying?
Well, I mean,
and you're trying to raise money from
we
them.
had to be very polite back then, but it's. I mean, we just showed them the physics, showed them the engineering calculations, but I think it spoke to the fact that sometimes the things that are really obvious, are the least intuitive. And there was this deeply seated belief that electric cars had to be slow and they had to be short range, and they're sort of people just formed that belief and then didn't want to change it, even though the technology in the batteries had changed substantially. It actually doubled from when GM built the EV1 to when we built the Roadster.
So there was a constant improvement going on.
There was a steady improvement that had happened in almost that decade in between, when everyone else had sort of looked at it 10 years ago and said, nope, doesn't work, and then they kind of put on blinders and forgot about it.
Right.
That was the single thing, I think, that really gave us a huge window of opportunity to start the company and to start it with a toehold with new technology while people weren't paying attention to it.
Yeah. Do you think also the fact that you could design things on computers, test them, I mean, that gave you a way to go?
It definitely helped. We could simulate the crashes and simulate a lot of the work on computers, as you said, without having to build quite the same level of infrastructure of engineering and test facilities.
Well, I learned at the dinner table from John Woolard that you found a very interesting way to crash test batteries, and you might describe how you did it.
Well, it wasn't all that precise, but we didn't really have a crash test facility, like the beautiful things that Toyota or GM have.
They cost money.
Millions and millions of dollars. So we needed to test the battery safety, and we realized we could basically simulate this if we just hauled things up in the air and dropped them. So we managed to rent a crane, which was a lot cheaper than renting a test track, and would lift things up and then end up dropping them and
From several hundred feet.
or at least many tens of feet. We kind of
Right.
stepped it up to
Right.
understand what would happen. But that was a really shoestring way of making it work, and
And it did work.
it did
Yeah.
work. We learned a ton, and it was a really fun time. I'm
Right.
probably glossing over all the really painful things, but it was it was fun, and we we're innovating at an amazing pace, with a very small team with few resources.
Right. So it's funny you mentioned the painful times, because I just thought I would just ask you about the painful times.
Are we going to get to the fun? The fun
No,
stuff
we're going to
here?
get the really fun stuff. Just tell us about your moments of deep despair.
Well, there were many times when Tesla was on the brink of running out of money. Those were definitely not fun times. As a startup, we were constantly between 3 to 10 months from running out of money. So that's a pretty short runway when you're trying to invest and build a company and build a product that takes years to make. So we had to keep kind of going right to the brink, to try and get milestones and demonstrate things that would convince people to give us enough more money to get a little more of a runway to demonstrate some more. And that whole time was pretty stressful. It just was.
But you always believed. You didn't.
I always believed in the technology. I have to say there were plenty of times when it felt like it might be a hopeless business activity. I think Elon has talked about this as well, and it's having just this sort of deep conviction in what we were doing. All the people at Tesla, still today, having this deep conviction that where we were going, what we were trying to achieve was worthwhile, makes that possible.
Right.
Otherwise, if you've sort of reached a point where you're like, we're probably more likely to fail than succeed, the rational person would stop doing that.
Right. Get a job.
So that having that conviction in what we were doing made those incredibly painful and difficult times, more possible.
Right. As you look back, were there 2 or 3 really big technical challenges that stand out that were the real kind of key points?
Well, I think some of the aspects around battery safety, were really key points. They weren't as well or as much focused on, but we had to learn an enormous amount about how to make relatively large lithium-ion battery packs safe.
Right.
In a vehicle setting, which no one had done before, and sort of necessity forced us into some very, very I think interesting innovations and inventions in that time frame, which have still stuck with us today and have kind of become kind of core principles that we design all of our packs to.
Maybe give a sense of what you had to do on the batteries to achieve what you needed.
Well, fundamentally, whenever you're storing energy, you have to think about safety and about how to manage short circuits and release of heat or release of the energy. So we had to think about how could we take what is a large amount of energy and a large power capability and break it up in the most efficient way so that it would be very rugged and very robust, even if the car was being crashed or caught in a fire or all kinds of other horrible scenarios. So, through that, we were able to invent, cooling and fusing architectures and kind of the way that all the cells are connected together in a way that really solved some of those safety problems fundamentally. And
Right. We noticed that you didn't start this company in Detroit. How important was the Silicon Valley ecosystem? I know, just a lot of generalities around that, but that you were in that culture.
I think the culture is the pivotal part. Being able to have a culture of employees and talent, that we could recruit from that was willing to take the risk, frankly, to join the company in the beginning. That would have been, I think, extremely difficult, really, in many other places in the world, almost anywhere else.
Were a lot of them from Stanford?
Many.
I should say there are a lot of MIT people here tonight, but were a lot of them from Stanford?
In the beginning, it was that way mainly because it was us recruiting from our networks.
Right.
we had no brand name. We couldn't really recruit anyone that had a serious engineering track record, because why would they come and join this craziness? So it was sort of me hiring every friend that I knew, and then they would all go and hire their friends that they thought that were good employees. So we kind of grew fractally like that, and that sort of tied us to Stanford and to the Stanford community, pretty tightly.
Right. So, right next to Stanford is Sand Hill Road, where many of the venture capital, most famous ones were, and of course that was the era of clean tech and Web 2.0. What was the reaction when you went to see most of the VCs with this idea?
Phenomenally bad. We basically got almost no traction for the first several rounds of the company, and it was. Elon was directly involved in the company, but it was really his, willingness to back this idea, even before clean tech was a term, and when none of the VCs would even really take us seriously at all. And it wasn't until really our Series C round when we actually started to get some traction with the venture capitalist community.
Right. And within Tesla, I've talked to one of your directors, and he said that this kind of secret of the company is what he called the innovation engine. And when we talked the other day, you said, don't romanticize innovation.
Yeah, I think that's something I get asked all the time, which is, what is the secret sauce for innovation?
Yeah.
Or how does Tesla do this? We want to emulate that, or we want to be like that. And I think from the outside and from looking at the results, it looks like a fun, happy thing. But innovating at this incredible pace and disrupting our own products constantly is really painful. It's brutally difficult internally. It's stressful. People are burning out, and it really is a hard environment. And we kind of impose it on ourselves because we feel that we have to. That's the only way we can really survive in an industry with so many huge companies, with so many more resources than we have.
So is there a lot of conflict in that kind of situation?
I wouldn't say conflict. It's really more stress around schedules, stress around functionality, and around timelines of trying to get products developed, get them validated, get them launched into production. So we essentially just never take the initial answer.
Right.
We sort of understand what the initial answer is, and then go back to the fundamentals and say, well, how fast could we possibly do that, or how light could we make it, or how cheap could we make it? And that's sort of a culture that's pervaded through the whole company.
Yeah. When did you feel? Of course, you can't ever feel that you rest on laurels, but when did you feel that you kind of crossed the point to where you could say that this was the first new American automobile company launched since 1925, that you kind of feel, well, we finally got there?
And sometimes we're still waiting.
Right.
I think that's another characteristic, is that we never really kind of sit back and look at what we've done and think about that as we've made it. I guess we're constantly sort of tearing up what we did as soon as we've done it and looking to the future. To us, the next vehicle we're in the middle of right now, the Model 3, which is our mass market car, is what we're kind of aiming for to think when we may have really made it to our mission, or really started to prove that electric cars can be adopted by millions of people.
And what's the timeline for the Model 3?
Well, we're actually launching it. We have the unveiling of the product at the end of next month, so March 31st. It's pretty soon, and starting to production at the end of 2017.
Right. Are you taking orders tonight?
Not quite yet tonight. On March 31st is the first day we'll start taking orders.
Right. There's been so much discussion over this entire week about the key question about batteries and battery costs. And how do you see battery costs, the degree to which they've fallen, and how much more can they fall, or do you have a view of that?
Sure, it's something we spend a huge amount of time on. Nothing else has more leverage to the electric vehicle business than the cost of batteries. And it's been a very, very rapid decline. I think more rapid than most people expected. In some cases, more rapid even than we were expecting. But the exciting thing is that it's not anywhere near the end. We're still at the very infancy of really the volume maturity of the battery industry. If you think of the percentage of the vehicle fleet that's actually electrified right now,
yeah.
it's infinitesimal. we're selling tens of thousands of cars per year. Even if you add up all the other EVs in the world, and the Model S is really one of the best-selling EV. If you add up all the other ones, it's still way less than 1% of all the new cars sold.
Right.
So, if you think of what can happen as that volume curve starts to go up, the price reduction capability is enormous. And that's just the vehicle market. If you add in the utility sector and the stationary energy storage products and markets and demand, we see many orders of magnitude more production capacity that will have to be built, and that can drive down costs faster than people expect today.
Right. So we'll come back to that in a minute, but to just pursue on the lithium-ion battery, a few years ago, well, what would it be, about 8 years ago, 8 years ago, there was lots of talk about peak oil. It turned out it's not the problem now, right? Some people express concern about peak lithium. I mean, when you look at the resource base, is that something that you pay attention to?
We do, but it's definitely blown far out of proportion. There is a huge amount of lithium. The resource is extremely plentiful. And if there's anything that we kind of keep some focus on, it's the refining and extracting capability. What's the capability to take the resource and get it into the refined product we need to build batteries? But overall, there's a massive amount of lithium. I mean, it's actually one of the more prevalent elements dissolved in seawater. And it's not economic at today's prices, but you wouldn't have to raise the price very much, that you could even start extracting it from seawater. And the other point that I think is lost often is that lithium doesn't make up that much of the batteries. It seems like it should because it's a lithium-ion battery. You'd think it's full of lithium. But in reality, the price of lithium in the battery is single-digit percent. It's a very small percentage of the overall total. There's actually much more nickel in the batteries than there is lithium. So it really should be called a nickel graphite battery, but instead it's called a lithium-ion.
Yeah, that would be less attractive.
Less sexy that way.
Yeah, exactly. And so we're not running out of nickel, so no. The reaction of the rest of the automobile industry, what's your sense of how they responded to you?
Well, it's been fascinating to watch. It's gone through a whole arc, and it's still progressing in terms of how they relate to us. With the Roadster, it was kind of fascination and curiosity, but no one really took it seriously. They didn't, feel like they needed to. It was kind of a one-trick thing, and we sold a few thousand of them. So what? But with Model S, it started to change. There was quite a huge amount of denial, I think, in the beginning when we launched the Model S. First people telling us that we had no idea how to build a car, we'd fail, it can't possibly work. We've never built a car before. There were predictions that we would sell in total no more than 3,000 Model S's.
How many have you sold so far?
Close to 100,000 now. This is a fleet size.
All right.
But these were really unhelpful predictions from the car industry because our suppliers would then go and tool up for a maximum volume of 3,000 cars ever, and we would then have
the supply chain.
We'd have supply shortages. Surprising. But then, as the Model S matured in the market and started to win some of the very critical automotive awards, the Motor Trend Car of the Year, that was a huge deal. That was kind of a shocker, and winning great praise from Consumer Reports and some of these other very independent and very critical reviewers. That started to change people's mindsets. And all the car companies bought Model S's. We have tracking in every car,
right.
So it's quite fun to see them all showing up, in Stuttgart.
Did they use
and
pseudonyms?
Munich.
Yeah.
So
fake names.
I think what they sort of experienced there and learned, and what they've heard from customers too, has changed the mindset. And now if you go to any major car show, every single manufacturer has some electric or plug-in hybrid offering.
Right.
It's really pretty exciting how fast that's changed.
Do you see, there are some Toyota who look to hydrogen instead. Do you see hydrogen as a fuel cell as a competitor?
Really not at all. Maybe it's a controversial point of view, but we've been watching hydrogen and tracking it and looking at this for well over a decade, and I just don't see that as a competitor at all. And there's so many fundamental problems with hydrogen as a transportation fuel. The infrastructure cost and the chicken and egg problem with infrastructure is a major issue. The actual energy cost is a big problem that gets completely glossed over, but the cost per joule or BTU or unit of choice for hydrogen is very high. And if you equate that back to cost per mile of mobility, it's very high. And as soon as I think that gets through to people's mindset, that'll be a challenge. The overall efficiency of that pathway, is if you want to power it sustainably, is really quite poor. It's probably half to a third as efficient as going direct from renewable generation through to charging a battery. Right. So I could go on, but generally, no.
I think we see where you're going. When we talked the other day, I always assumed that you named it Model S, sort of like Model T, but you said that was not, you didn't spend a lot of time on the name, and that wasn't necessarily the reason. Yeah,
we're pretty bad maybe at naming things internally. We don't hire big marketing companies to give us a bunch of options. We sort of just sit around a table and throw ideas out, and somebody likes one. But we were thinking more Model S for a sedan. This is our sedan model, and then later we would have the Model X, which now is our crossover, sport utility vehicle model. X for crossover. So yeah, we didn't really give it all that deep a thought in terms of how that would really play with the history of the Model T or something like that.
Right. Well, tell us about the Model 3. I mean, because that's, as you say, that's the car that could really be very significant because it has a whole different price point.
Yeah, it's incredibly exciting. I'm super excited about it. It's really why many of the employees at Tesla have come to Tesla. That's kind of the product and the car that they want to make to change the world. And this is our what we think of as more mass market vehicle. It's about a $35,000 price point to deliver 200 miles of real world range, and that's less than half the price of the Model S. So in a single product generation, we're able to cut the price in half. So it's
Is it a smaller car? I mean, just what does it look like?
Well, I can't kind of give away everything ahead of our opening event, but it is a somewhat smaller car. It's if you think of the Model S as sort of more in the equivalent of a 7 Series or a 5 Series BMW. Our Model 3 is closer to like an A4 size of car from Audi or something in that range of size. And I think it will surprise people though with the level of sort of features that it includes. And overall internally, I'm more excited about Model 3 than at this point I was about Model S.
So is this something you've been working intensively on?
Yeah, many of the sort of engineering groups inside of Tesla are focusing quite a lot on this. It's a huge effort and something we've been working on for years. So it's a next generation on most of the technologies that we've done. Right.
In terms of the market, you mentioned that you have a newsletter. Tell people how many subscribers you have to the Tesla newsletter.
Well, it's over 1 million subscribers today, which is pretty surprising. When we think that our total customer base is less than a tenth of that. I think that the ratio is around 10%. Right. So it's indicative of how much excitement there is for the brand and for what electric vehicles can do. The biggest problem with the Model S and the Model X is their cost. We don't really need more performance. We don't really need much more range. We need to focus on cost.
So without, again, giving away secrets, can you say something about what you did to bring down the costs?
Well, it's a huge number of innovations. The battery is the biggest piece, of course, and the Gigafactory and driving up the supply chain on how we build batteries is one of the enabling factors to bring that cost down. But there are many other things that people don't think as much about. Electric motors. We're driving down the cost of motors, of control electronics, of wire harnesses. Basically every single part of that electric vehicle ecosystem is dropping substantially.
Right. So should one think of Tesla both as an auto company and a battery company?
Well, fundamentally, most of our revenue, most of our products right now are cars. So from that viewpoint, yes, we're a car company. In my point of view, and I'm a bit biased, but I really see internally a deep expertise in energy technology and energy innovation. Many of the things that we're moving forward and enabling to make better platforms of cars, don't feel that much like automotive engineering. When you get close to it, we're doing power electronics engineering. We're engineering magnetics and motor design and battery modules or cells. So only at the last level does it all come together into a vehicle system. But I think some of our most impressive work, in my view, has been in how we've innovated on those energy systems beneath the skin of the car.
So tell us about the Gigafactory and Tesla Energy. I mean, because that is certainly
Sure.
above and beyond cars.
Well, the challenge that we, maybe and also a big opportunity that we identified with Model 3 was that as we made the next leap up in volume, from tens of thousands of cars per year to hundreds of thousands, we would have a supply constraint problem with batteries. The Model 3 alone, around the end of this decade, would consume more lithium-ion batteries than the world produced in total in 2013. So, this was, clearly a supply challenge of pretty major proportions. But we kind of turned that around and said, well, actually, this is an opportunity. Instead of just building more and more batteries with the same consumer electronics companies and with the same methods that Panasonic and Samsung and Sony and LG Chem and others do today, we could rethink this and say, with an order of magnitude more in scale, we should be building batteries differently. And we should have a different type of factory that's more attuned to vehicle demand needs and the scale of that and to the grid energy scale of need. So that was our vision for the Gigafactory, was pulling more suppliers together, pulling more operations together, and making a vertically integrated factory that could go essentially from raw materials all the way through to finished battery packs.
Right. And so what's volume is it scaled to?
Well, the initial sort of thinking we have is on the order of 50 gigawatt hours per year of outputting battery packs, which is a pretty huge amount of total energy storage. It's far more than the world has done to date.
50 gigawatts.
Gigawatt hours of energy storage per year, with about 35 gigawatt hours of cell production happening right on site. And 35 gigawatt hours was about the amount of storage that all of the companies in the world, as I said, built in 2013. So even when we launch this factory and turn it on late this year, it will be the biggest battery factory in the world, and then it grows very quickly from there to support Model 3.
And that itself has required a lot of innovation.
Absolutely, and we've taken a pretty different approach to this, which is not looking at it just as a factory, but thinking about it more as a technology and as an engineering problem. Because the cost of the battery is determined by the materials, but also the manufacturing capital cost, the factory to build it, the labor cost, the energy cost. And to make a huge dent on energy storage cost, we have to improve on how the battery is actually built. So we've launched several engineering teams that focus on basically building the battery, more intelligently, reducing the energy need that goes into the manufacturing, reducing the labor, increasing the throughput, decreasing capex.
Right. So and you've had to design whole new production lines and.
Yeah, and we've had some pretty interesting successes there, and forced some innovation into an industry that had been going a little bit more slowly. And Panasonic has been a fabulous partner with us on this project, and
so they are your partner.
They are our partner in the Gigafactory, and it's a great kind of yin and yang between the two companies. Panasonic,
is a somewhat bigger company.
Somewhat bigger and somewhat much more established in their processes and traditions, and they're just a fabulous manufacturing company. Their quality control and their ability to do, especially precision, chemical engineering and chemical processing is the best in the world. So, that combined with kind of a more innovative, this kind of faster moving approach to kind of keep pushing and pushing is a pretty neat combination to make good improvements.
Right. And then Tesla Energy, what does that do?
So Tesla Energy is a business unit that we launched last year. And it's something we've been thinking about for quite a few years. But basically that takes the same battery innovations and architectures around safety and cooling and even the supply chain costs from the automotive side, and we apply that back to the utility sector. So we basically repackage and re-architect those batteries into products that can be used in people's homes, in businesses, and even at larger scale, to support utility loads. And those products are what Tesla Energy is now marketing, commercializing, kind of in a whole different channel.
And do you have a sense of the cost?
The cost of the.
I mean, in other words, what's been said here constantly is if the cost of batteries for storage comes down significantly, that's a kind of potential game changer.
Well, I think one of the things that we were able to kind of surprise people with and shake up the industry a little bit was launching even our first wave of products last year at much lower cost than people expected. And our utility pack, just the battery itself, for instance, is in the neighborhood of $250 a kilowatt hour. And we had a residential product that was below $500 a kilowatt hour, close to 300. So this was almost 10 times cheaper than some other competitors were selling products for.
Right.
So the mindset in the market was that these packs were over $1,000 at residential scale, and they would take years and years to come down. But because of the volume from our vehicle business, we'd already achieved this economy of scale, and we can achieve those savings into Tesla Energy almost immediately.
Right. So what has been the reaction? You've had dialogue with electric power companies, utilities. What's your relationship with them now?
Well, it's we've had a long relationship with many utilities. It's kind of twofold. We have the vehicle business, which is, I think, a very exciting development for most electric utilities. It's as electric vehicles grow and proliferate, it's one of the biggest load growth. Products out there in the electric sector, and that's a pretty exciting thing for the utilities that are facing load destruction in many other ways. So there's a great relationship around supporting EVs, around enabling EVs, and just making that a better experience. And then on the storage side, we can leverage those relationships to start to tie in residential storage, and to think about how can we then aggregate some of those residential storage systems in the same way that we today communicate with and aggregate cars. And the reception on even the larger systems, the utility scale systems, has also been pretty exciting. Just a few weeks ago, we announced a project in Hawaii that's, I think, the first of its kind in the world, where we're working directly with a large utility scale solar installation, putting large storage right next to that, and then selling firm energy contracts from a solar farm.
How big is the storage?
The storage for that project is 53 megawatt hours, and it's I think about a 15 or 13 megawatt photovoltaic installation.
Right.
And we're actually able to, in partnership with Solar City on this project, we're able to basically deliver that energy into the night. So every single day, that battery is absorbing solar during the peak generation time, and then providing it back to that grid on Hawaii when the peak loads are happening in the evening.
Right. You said that, you're obviously, Tesla Energy is something you're quite involved with right now, and you said it sort of takes you back to working on the Roadster. So just kind of how involved are you?
Well, I'm definitely very involved day to day on Tesla Energy. It's something I spend a huge amount of my time on. I really enjoy, building things, not just products, but also enterprises and teams and companies. So, with Tesla Energy, it's a newer endeavor. We're starting with a smaller team. We're starting with fewer resources and trying to bootstrap, its way into growth. So it's fun to kind of, reverse back in time a little bit, and, not have quite as many resources, and not be not have as much revenue or all the other kind of, luxuries that a bigger company has.
Right.
And it kind of helps inspire the team, and it can kind of engender a little bit more sense of ownership from a smaller team.
Right. So I guess it's 2003 really 2004 when Tesla started. That's 12 years ago. If you look out 5 or 10 years, kind of tell us, do you have a vision that motivates you now of what you see?
Well, I'm pretty excited about, in the 5-year time frame, how much growth we're going to see from Model 3 and that sort of platform of vehicles. I don't think out of this question that we'll be having millions of vehicles on the road in those sort of 5 to 10 year time frames. The growth rate is pretty extreme, and the improvement in technology, the improvement in costs, is much more than people expect.
Right. So when you go back to the Stanford campus and meet the students who are now in the major that you started, and they ask you for the lessons, do you have some ready lessons that you draw from all of this? Or have you time to think about lessons?
Yeah, it's always a bit hard to digest those things for But I think the thing I usually am telling students is just to follow their passion. And it seems like a super obvious thing, but I see so many people still kind of forget that, and they follow trends instead of their passion. And it's again hard to remember that everything that we were following when we were starting Tesla was the anti-trend. It was not trendy. It was not.
It's not trendy to start a new automobile company in the United States.
Or clean tech or energy tech or any of it. I mean, basically on every vector, it was kind of just anti-establishment and weird. So it was something that we were doing because we loved it and we were just crazy passionate about this. And I think that is really the key to sort of get students to find what that equivalent is for them, and then to just go fearlessly and follow.
And so you all gravitated and were just motivated by this idea, and it would have been hard to do it other places, but
yeah, and there just wasn't much activity happening. None of the car companies were building electric cars. You couldn't go and work at a car company and do this. And
right. You said something that, and we were talking the other day, that I've reflected on and thinking about the meaning of it. You said what you did was not reasoning from what's been done before, and maybe you could just explicate what that means.
Well, I think that's something that culturally we constantly do, which is we don't try and look at examples that exist today and then sort of go from that to improving that slightly. We go from fundamentals. We look at what's possible with physics and with science and with technology, and then we base our product decisions on that. So it's, we often call it reasoning from first principles or going back to first principles. And I think if you can challenge engineers to do that, it often breaks through a lot of preconceived notions. And many times people don't do that. They sort of see what was done, then they kind of take that for granted, and then they build on it. And it's more powerful if you can start from a clean sheet of paper.
Right. Well, let me tell you that everybody here is going to look with incredible interest in about a month from now when we see the fruit of your current, not reasoning from what's done before, in terms of the Model 3. And I think everybody here tonight is, by definition, very interested in and very deeply engaged in energy, electricity, what the future is. And so on behalf of everybody, I want to thank you for an incredibly enlightening evening. Thank you.
Thank you very much.
So let me just take a word to just say what is tomorrow, and tomorrow is kind of what tries to bring it all together. The breakfast dialogue is reflections on what we've learned from CERAWeek 2016, including what we've learned tonight. And then we'll be talking about demographics in the second machine age. And then with former Deputy Secretary of State Bill Burns, we'll be talking about prospects for the Middle East and the world. And then our friends from MIT will be talking about some of the great innovations and technologies they're working on for tomorrow. And then finally, we'll conclude with a plenary on U.S. and global energy futures with Senator Lisa Murkowski and John Cornyn. So we'll see you tomorrow morning, but again, let's just thank JB very much. Thank you.